Hmm. Hey, John.
Hey James, how are you?
I'm good. I'm good. How about yourself?
Oh, a little sick today, but other than that, okay.
Oh, okay. So, what did you say again?
I'm sorry, what was that? Wait, wait, I gotta turn up my
Oh,
headphones
okay.
here.
You would say something earlier. I didn't hear that.
Oh, I'm just feeling quite sick, but
Oh,
other than being sick, I'm good.
I see. Sorry to hear that.
Yeah, it's okay.
I guess because of the weather, right? The fall. I feel.
Yeah, I think
Yeah.
so. I think something's just going around as well.
Yeah. Yeah. I have a sore throat. I think I for a week now,
Mm.
and trying to recover. Now I'm always having some coughing, but I'm feeling better. Yeah. Hey, Rudy.
Hello.
Hey. Yeah, I can hear you. How you doing?
All right. Yourself?
Not bad, not bad. We just kind of talked to John. We having kind of like cold and not feeling that well. I think maybe because of weather is like turning cold.
Yeah, we had a snowstorm last weekend, so yeah, definitely.
Oh, where you at?
Colorado, we got about 5 to 8 inches on a.
Oh, okay. So sounds like the skiing season is starting.
It is a couple places are open, but I usually don't start till Christmas or after Christmas.
Ah, I see. So usually you get the season pass. Oh,
Yes.
okay, that's nice.
Yeah. Yeah. The thing they don't tell you is they got 30 to 36 inches of snow, but they'll have 40 inches of rock, so it takes quite a bit of snow to cover it up.
I see. That's why I wait for a bit more to come out. Got it. That makes sense. Hey, Angel. Hey,
Hi,
Mutu.
everybody.
Hey, Prayus.
Yeah,
Hey, Andrew. Hey, Andrew, do you get snow at your place right now? We were talking about snow. I think I with Rudy,
S-
the Colorado. We
No
talked
snow,
about
no,
it.
no, not in the UK. We very rarely get snow in the UK. It's very wet and windy here, but no snow.
Oh, okay. Not on the mountain or like.
Well, we don't really have mountains in England. There are a few in Scotland, but no, but not near us.
I see. So where you guys go to ski then?
Go to Europe,
Oh,
Switzerland or France or Italy,
right,
in the Alps mainly.
right.
Yeah, it's not easy for us to ski. We have to get on a plane normally.
Oh, okay. Not a train?
Sorry?
Oh, not the train. I thought there's a train to Europe too.
Well, yes, you could get the Eurostar to Paris and then get on a train from Paris to the Alps. People normally fly there. It's the easiest way.
Right, that makes sense. All right. Not sure if Tony will be joining. I didn't hear from him, but let me quickly share. I think the agenda here. I think I just shared earlier with everyone.
No, Tony will not be joining. He's traveling this week.
I see. Okay. All right. I guess we can get started right, with what we have. So can you see my screen? So I'm just pull up the. Yeah, we didn't have the meeting on the previous. I think 2 weeks ago we have that OCP Global Summit. So a few of us attended that. It's very exciting. I think we have a lot more crowd this time compared to last year. So I think it's about like 5,000 head counts. There are a lot like kind of like the data center cooling stuff, but there are a very good section for the semiconductor and chip related. We have that Thursday morning that we presented from the entire ODSA group, the server group here, including a few of us, David and Tony and Jawad presented. I think chip related. So yeah, I think it was very exciting event. I think we could see more of you guys like coming joining in the next time in future. And from the previous meeting, I think that we had, I think on early October, I think we talked about we covered I think this spreadsheet. So let me open that quickly. We just kind of recap, right? So we started with this initial spreadsheet, and then we have a few discussions. We expand the component analysis, and we talk about dimension. And then Andrew created this property list. I think based on the materials, properties for simulation. That the NC has experience with. So I think this is a good list, right? Everyone can agree from previous meeting to start with. So I think and based on this list,
Hey,
so
hey guys, just joined in. Can you hear me?
Yeah, I can hear you.
Okay.
Yes. Are you saying something or? Hey, Tony.
Nope. Yeah, can you hear me?
Yes. Great to hear from you. Yeah, I'm just kind of like go over the review what we have from last time and step where we are right now, and also going to that the agenda from previous meeting that we talked about. So we talk about I think like the race coming to I think this is the list that I think I expanded from Andrew and then from the original list, property list here. And then we from there we talk about I think like Andrew can add more I think composite properties to the list, and then we also like propose I think Moodle can help with adding the bonding related properties to the list. And then we can help to use a different model and use cases right to help to expanding and cover the properties like what we have. And then yeah, we also talk about like key site might have a lot of insight into it. We might have people potential can participate. It will be helpful to participate in this, so we listed that in here. So so that's coming to this list. Yeah, and with this list, I'm just trying to go over and see like if any of you have any update on this one, and then we can start covering on this. Yeah, Tony, since I hear you, anything else you want to add on this list for the agenda today?
No, I'm in my car, so I can't really see it that well. I'm just going to listen in.
Okay, all right. So we'll start with this list, and then we will discuss whatever does come up there. Yeah, Andrew, do you get a chance to work on the composite property to add to the list, or?
Sorry, muted. Yeah, there was only a few. So if you go back to the Excel sheet, I'll just point those out.
Oh, okay.
So yeah, for the only ones I've added is if you go down to row 18 and 19. So yeah, so I mean for failure in composite laminates, you normally use something called failure criteria, which is you have criteria where if the stress or the strain goes above a certain limit, then you assume that that ply has failed, and in that way you can kind of try to predict damage. So one ply fails and then the load is distributed to other plies, and that could cause complete failure, or it could just cause gradual damage of the composite. So there's that, and then the other one is the 19, so that's the delamination and debond strength. So this can be used for either kind of bonded surfaces, or it can be used for delamination of laminates. So again, there's kind of two models there, which, at least in our software, in the ANSYS software that we use to model the debonding of surfaces. And you generally have different loading modes. So, you know, you can have loading mode 1 is when it's just kind of opening up. Loading mode 2 is where you've got some kind of twisting failure, and loading mode 3 is where it's more shear, or it might be the other way around actually, but anyway, doesn't matter. So yeah, so I think that was in response that, you know, some people were asking, well, what about composites? And so yeah, I've just added those in response to that.
I see. So okay, model here, parameters. I see. Got it.
So all the other ones are the ones which we had from the previous meeting.
Right, right. Is there any like kind of like the unit or formula associated with this?
Yes, I mean, yeah, I mean, most of these will have units. And in terms of the formula, well, yeah, the kind of models will have a formula behind them. But, you know, I think that's where I kind of mentioned last time, it's how far we want to go down this route, because when you start to specify models, you're then getting you're getting quite specific to a particular simulation code. You know, and it gets more difficult to make this agnostic, you know, to make it neutral.
Right, but I think like maybe at least the common one, maybe we should include. I think like at least maybe if would be nice. I have a common one, at least the basic one, and then we don't have to extensively to cover all of them. Right, maybe a few most commonly used. I think as an example, I think like some structure we can use that as a kind of like create the structure so that we can accommodate like any other formula or unit that will be used. What do you guys think? What do you think, Andrew?
What? Sorry, are this kind of background noise? It's a bit hard to hear.
Yeah, I think someone in background noise or the
Is
Yan.
it Yan? I think Yan. Maybe
yeah.
you haven't. You've got your.
Yan, can you mute? Yeah, I appreciate that.
Sorry, could you say that again, James? I
Yeah,
didn't catch all of that.
yeah, I was just kind of like mentioning. I think I have an opinion about. I think at least providing some common or popular ones, at least, or one or couple of them, at least using as an example. So like as a use case and how the structure should form. And then with that, I think hopefully that structure can be fit into other formulas or units that way. But we probably not necessary to extensively including all of them or that way. Does that make sense? Or at least have something there. I think and for one reason is for at least form basic structure so we can kind of accommodate the unit and also the formulas that we can cover. And then secondly, I think as kind of like more kind of like the template, right, for other people when they want to accommodate other unit and structure, they can use that as a reference to incorporate that.
Yeah. Excuse me. Yeah, for putting the models in, it's quite tricky. Because do you want those models just to be, if you're putting in an equation, do you want that just to be human readable, or does it need to be machine readable? Because putting machine readable equations in is, there are different ways of doing it. So what we would generally do is that you would specify the material model in the file, and you would specify the values of the coefficients that go into that model. But you wouldn't specify the actual equation itself because that would be embedded in the actual solver code. So again, it depends on why we want to put that equation in. If it's just so the user can look at it and see what it is. But to be honest, most users wouldn't know. They would know the model by the name of it. They wouldn't necessarily know what equation that model took. They just know it as, as a Mooney-Rivlin hyperelastic model. They wouldn't know what it looked like in terms of the equation.
Yes, I think I could. I would think about what you mentioned makes sense. I think we not necessarily put formula, but we can at least put some sort of like describing some sort of structure that they can accommodate that, like what you just say there, put in something there. I think we can just as like a framework, and we can we shouldn't worry about I think details about how we're going to implement that. I think we can work out on that after that. I think once we have that structure. So with some experience, I think here when we do the CDXML and also that JDEC, we do have some sort of structure can accommodate that we can reuse to accommodate this.
Yeah, I tell you what, the easiest thing might.
Hey,
yep, go ahead.
Yeah, can we? Yeah, I'd like to just discuss this a little bit. So, it is the challenge that these equations are too complex, or what is the issue about having the actual model machine readable?
Well, because when you're specifying a material model in a solver, you don't normally specify the equation. You say, I want to use this model, and here are the input coefficients for this particular model.
Right.
Okay.
You're not specifying how the modeling is done in any EDA tools that I know of, Tony. Everything just requires the input. So at least on the electrical side, it's very straightforward, right? You need, if we're talking about, dielectric constant, loss tangent. The model that's run in the background is just predicated on those two values, not anything else. The background equations don't matter for the user, but the inputs are important. And I think that's what Andrew was saying.
That's right. Yes.
So are these
you have the name of the
models
model, and then you have the inputs. You know, input 1, input 2, and.
So the name of these models, I mean, are these standardized, or are they unique to different vendors' tools?
Generally, most of them are, you know, they're kind of standardized, but they might be implemented in slightly different ways within each tool. So even if it has the same name, 2 different tools might have a slightly different implementation. So the inputs you put into one might not be the same as the inputs you put into the second one, which is why I was suggesting that once you go down this route, down the model route, you then have to start thinking about, well, you know, do we have to then start thinking about how neutral this could be? Because you know, I know certainly that, you know, that we have answers, you know, because like I said, that my background is in mechanical. So ANSYS and Abacus are 2 very well-known ones. They both have a hyperplastic model called Muni-Rivlin. I can't use the same inputs into both of those because they work in slightly different ways, even if they have the same name. I don't know about EDA tools, but certainly within the mechanical world, even if those models are called the same thing, doesn't mean that you can use the same inputs into them. Some you can, but a lot of them you can't, especially the more complex ones.
Yeah, let me interject here, please. This is Muthu. Actually, we had a lot of experience in these type of issues. When you go for a very specific advanced packaging issues, I mean, I'm talking about the packaging side, then these models are not very user-friendly for us. Example, you take creep issues, or even prediction, life cycle prediction, it's totally out of our range. This is simply because, just Andrew mentioned, even the choice of model itself is a huge issue here. You don't have an experimental evaluation on any new composite material. Your constants are going to be, your coefficients are going to be totally different from what you are actually taking it from elsewhere, or from literature, or from white papers, wherever you are getting from any resources. That's going to be totally different. So today, everything is changing. So the coefficients will be totally very different. And also in the choice of models, just now Andrew mentioned kinds of, either you are going for viscoelastic or plastic, it all depends. EDA tools are a little different, pretty much standardized. But today, when you go for chiplet kind of issues, especially for packaging, I'm just purely talking about packaging side. So if you go for that packaging side, packaging predictions, or even the life cycle creep, whatnot, you got an umpteen number of problems. Today, we are all suffering. We are now going to ANSYS, we are going to all that material, I mean, these type of, you know, software people to look, I mean, we are talking to their R&D, or even to their, the people like Andrew, we are looking at what type of equations behind, what type of models built, what are the equations behind it. We are now trying to understand it, first of all. When you are saying a very generic model, James, it's not going to be suitable. Viscoelastic has 25 models. Which model you're going to prefer? So it all depends on user-friendly. But I pretty much understand you are now generalizing it just for big picture. Later on, the user will go and pick it up deeply in the next phase. That's what you're trying to say. I totally understand that. But now coming to this point of what Andrew's saying, you cannot put any simple formula. That's my point. It's going to be a little complex. Cannot be simply unit or formula is not going to help. Maybe we can we can map a very generic kind of properties, associated links. But later on, if somebody wants to go and deep dive and pick up certain parameters, let them go and do it deeply with the stakeholders.
Mhm.
This is
So,
my view. This is my view. Yeah.
Yeah. Yeah. So, I mean, can we just, are the model names unique, or can we define a unique model name? And it may be like, ANSYS.xyz model, and then have the parameters associated with that.
Yeah, I mean, that would make it fairly unique. I mean, we wouldn't want to list them all because,
Right.
there are dozens, if not hundreds, but you could certainly have a model name and a vendor name,
Mhm.
and that should make it unique. There might be some options, and then you have a whole list of input parameters. It's just that what is the when do we see that kind of data transfer is going to be used? Because that's one thing I don't think I've heard or seen documented. What are the different use cases that we're trying to solve here? Because
Well, I think we have a list, James, don't we, of different simulations that we're trying to support.
Yeah, I think we start working on this analysis.
yeah, but it's not so much that, it's kind of who's sending the data and who's receiving the data, and what are the kind of problems, or what are the use cases, i.e. Because certain of us work for research organizations, and that they'll be generating certain type of data, more complex data. Other data might come from a material vendor, which will probably be a lot simpler. You might be exchanging data internally, between two different groups. Is that, have we thought about how this format is going to be used, and who are the people on both ends of the format, and which tools they're going to be coming from, and which tools they're going to be going into? I just wonder whether that's worth documenting, because then that might inform us on how much detail we need to go to in the actual the data itself.
Yeah. Well, I think ideally the goal would be to try to standardize on a set of models. Whether or not we'll ever achieve that goal remains to be seen. But for now, what I'm hearing is maybe let's just define a unique model name and the parameters for that, and just the format for that. How those models get distributed is kind of a separate discussion. That may be built into the tools, or it could be a model that gets delivered separately. And just for ANSYS, how are those models? Are they kind of built in under the hood, or are they standalone?
They are, yeah. Yes, I mean, you can have user-defined models, but most people will use the predefined models.
Right. So I think that's probably how we're going to have to start with this. But
I think my point is that unless we really understand what the use cases for this whole set of data is, it's difficult to maybe kind of bring this to the point where we have a fixed thing, because then we can go down and say, yes, we met that use case? Yes, we have. Have we met that use case? Yes, we have. I'm just thinking that if you're just creating a format for data without any really clear idea of who the users are, and maybe you do, but I just haven't seen it documented.
Yeah. Well, I think we have to organize it and define a set of usage models, right? So, we could take our best guess, and certainly we can expand on it.
Yeah, I'm just thinking that that probably the group here, that they probably look at this from slightly different angles, and they might have a couple of use cases each. If we can try to correlate those, because I would never kind of build a database or a database structure without knowing who the users are and what they're trying to achieve with it, because you may just not put the right site of data, or you might not organize it in the right way. I know that simulation is key here, but where that data is coming from, and where it's coming from and who it's going to is a pretty key kind of something to document, because then we can make sure that we're going to meet the needs of that target audience and the data generators.
So certainly the source of the data in the model probably should be documented. So maybe that's one of the fields that we provide, model name, the source of where the properties came from and who owns the model.
Yeah, that's not really what I was kind of meaning. I meant that unless we document what the use case is for this format of what this XML format is, then I'm not sure that we guarantee that it's going to be, we're going to meet the needs of whatever users we're targeting this for.
Oh, sorry. You mean like, for instance, if it's supposed is computational model, meaning the tool needs to access this model, right? Like some software needs or a script needs to access this model, and maybe what are the inputs and outputs? Is that what you mean?
No,
Andrew?
well, it's really that who's generating the data and who's consuming the data. That's what I mean by the use case. It's like, we can write them in a form like, as a material producer, I want to be able to send my customers a set of material data for my materials so they can use it in their simulation tools. But you might also get a research company that says, as a research company, I want to be able to send the results of some kind of some testing to my clients. It's just that I'm not really aware of who the two groups are on either side of this file format, because basically a file format, the point of file format is that you can store data and then it can be used, someone creates that file and then someone consumes that file.
Yes, that makes sense.
So we probably all come in this group to say, with a different view, that I come from a software vendor. So basically I'm trying to get people to put data into a format so they can use our simulation tools. That's the view that I'm coming from but other people have lots of other views. If we can correlate those, then we end up with a good understanding of what use cases this data format needs to comply with.
Yeah, so there are, so I guess there are, vendors and research labs that actually measure the material properties, and so clearly whoever is generating that, we want to know who did that, so we know where that came from, and then there's got to be a model associated with that. And then there's the tool aspect of it.
Yeah, I'm trying to capture like this use case. Is that makes sense to everyone? I mean, I'm just kind of like capture what you guys just mentioned. There is that might cover it if we start populating this information. Would that help? So,
well, with this use case, I think the columns are that who's generating the data.
come again.
So I think
I think this is like data producer, right?
But you don't go down to the models and parameters. Those it's just who's like producing the data, who's consuming it, and then what's the reason for why they
purpose, objective. Okay.
Yes.
Yeah, and it's we're talking about these are predominantly simulations that are being done, right? So we should specify the type of analysis that's being done, who created who's providing the material properties, and who's providing the model, and those properties need to be associated with the model. But I'm not sure in this format who's actually using it would be in the scope of this, right? I mean, that's the idea is, you know, we're trying to set up a design environment where we're having, you know, all the material properties that are necessary to support an advanced package design, and maybe, you know, why do we in this format need to know who the users? Are you talking about the specific users or the persona?
Well, if it's always one user, i.e. the person who's going to be, you know, using the tools, and that's fine, you know. I wasn't sure of that, you know, that maybe I'm just not, you know, that I'm new to this, you know, these are design kits, so maybe you just do have one user in mind, and it's very clear, and that's good, you know.
Well,
that makes it simpler.
The white paper we're writing, you know, we define a bunch of persona. You know, there's guys who are doing signal integrity analysis, thermal analysis, you know, so I think we can define, you know, the persona who's going to be using these models. Type of analysis that's going to be.
Okay.
Well,
Yeah.
the white paper that we talk about,
Model source and model name, and then the material properties with the associated, you know, source of who created those properties. Seems like that's covers most of our bases there. Make sense, or?
Yeah, that's good. Yeah, and I hadn't seen that before, so that's.
Yeah, maybe I can share with people with the at the chat here, that white paper that we're working on the draft at the CDX. We causing to finishing on that. It's not published yet. And yeah, they will bring that, I think, to a committee. We causing to finishing by end of the year. So, but I think this probably a good reference material for everyone here, benefits to review it. We do, talk about, I think, let's go to that structure. As Tony mentioned, we do have that persona that we define, and then we do talk about like different steps and flow that we need to go into when designing the chiplet. Starting with partitioning, chipletization, and then with the architecture planning, analysis for there's some analysis, and then functional verification, physical planning, power, thermal, SIPI, STA, and also a mechanical as well. And lastly, also not the least, the testing as well. And on what important, I think here is the persona that we define here, including all the system architect, right? The packaging architect, materials, like designers, like system verification, like power and thermal, and everyone. And then another important also that we're connecting to the every chapter that we're going to, we have this kind of input-output tables that describing like what is the input requirements and what are the kind of description, like and then this one will be like the user persona, which is who owns it, right? This one like the SS, same for system architect. So if this is the output, so like means that this person will responsible to provide the output for this one, getting this input. And then with all this analysis describing this section, this person will responsible for provide this output, and with the description there. So you can see the patterns here, like for every section, we do have this input-output table. I think that might be a useful starting point there.
Well, yeah, James, I think maybe, you know, this is kind of a superset, and probably, you know, we need to define kind of a subset of these persona, but we might have to refine it to a little more fine granularity in terms of the analysis. Like thermal is a pretty broad category, but there may be, and certainly stress, there's lots of different kind of stress. So I think we need to articulate the specific type of analysis, and then just come up with a common set of persona that is really the end users who are going to be running these types of analysis, that are going to be consuming it, and you know.
Yeah, makes sense. So are you suggesting maybe we take some of this table and then we kind of like break it down and dive into a bit more details, including the type of analysis? that is required?
Yeah, I mean, let's just start adding another tab maybe and just defining the persona and the simulation type. Maybe, you know, if we could, that's probably a good place to start rather than this document that's kind of a little verbose. You know, let's try to get it into Excel is a machine readable format, but it's ultimately it'll be put in a different language, which is consumable. But I think just organizing this in a spreadsheet is probably a good way to structure it, and eventually we can start mapping that data into whatever, you know, the schema that we develop.
Okay, I think
I would, yeah, let's do that offline. I don't think we need to do it here, but maybe you could take a crack at that, and any volunteers want to identify who can help define those types of analyses that we want to cover.
Yeah,
and Andrew probably is, you know, stronger on the mechanical side, but we probably need some more electrical and other folks. So again, we're trying to keep this advanced packaging related and not go too broad or you know, drive ourselves crazy.
yeah, I think that makes sense. Yeah, so yeah, I can kind of create a framework. I think Andrew maybe can help to fill out. I probably take some whatever do you have that document and kind of start filling some of the draft structure, and then maybe can help to or dive into it or review on it. And not sure, maybe like Moodle can help. I think Moodle just dropped. It seems like Moodle has wrote like SP, I think that he has one package inside. Anyone else can help on that? John, are you able to help with some of this effort on the use cases?
Yeah.
Since you know quite a bit around this, I think like the models and things like that.
Yeah, definitely.
Okay, appreciate that. Any other volunteers?
Sorry, are you looking into examples of these, or are you looking into further categorizing what you just the columns that you have?
Yeah, based on this page, I think Tony, Andrew and others discussed. So yeah, we're going to try to create the use cases and based on analysis, and then we try to explain like who are the persona, who are the users, like who will be providing data and who will be consuming it. Define an input, output here, and parameter. This is just kind of a rough structure. I think we feel free, you can always expand and add more columns or kind of define on this one. So yeah, are you able to help on this as well?
Sure.
Okay. Yeah, appreciate that. Yeah, I will kind of starting putting a framework. I think based on that white paper that we have, I think at high level, I think I will need all your help. I think to kind of fill in a lot more details there.
Yes, that sounds good. So this is on the link. Yes, on the standard.
Yeah, let me share the link again. It should be on the link on the email that I sent out in the folder. As part of the agenda, I will send out in the meeting minutes later after today as well for the link. But I put in the chat just now also.
Oh, sounds great. Thank you.
Also include that white paper if you guys interested and can look into that. It's pretty long, 100 pages long, but you can focus look into that input output table and persona table and a lot of information we're trying to extract from there and simplify that. And then so it's only focusing around the material side.
That makes sense. Sounds good. Yes.
Yeah, thanks.
Of course.
Yeah, anyone feel free. I think I share a link. Feel free, just add it. I think there's no limit to, but I guess at least we have someone will take initiative here. I think initial I think effort here to starting this work here. That's good on around this topic. Right? Anything else that we need to cover around this on the component side? Let's go back to component properties. The composite components. I think Moodle, I think he has a PC problem. He's not able to cover the bonding properties, so we might not able to cover that. see if he comes back or not. If he not, then if he does, then we will follow up again. And we talked about last time, like regarding the key site for participation. Like Rudy, are you able to reach out to them or any one of them? Or
Yeah. Again, I've recently gotten the Keysight US Director of Partnerships. So my thought was to reach out with him. I won't say his name here just in case they do or don't want to, but I'll reach out to him and copy James and Tony.
Great,
all right.
thank you.
Yep.
Appreciate that.
Yeah.
Yeah, Roger, I just go ahead.
A little bit further down the road, you know, I think we are looking for some of the contributors here to provide some test cases so we can actually do some of this analysis. The CDX group is working on a sample design, and we might be able to build something. Yeah, this is down the road a little bit, but you know, I think we really want to at some point be able to demonstrate this stuff. And you know, let's take a very simple case, you know, maybe like signal integrity analysis or something pretty straightforward, and just kind of fleshing it out, and then we can build on that. So I think we could probably use the CDX test case once that gets a little bit further along.
Yeah.
And I know Intel has offered some generic test case for some designs as well, so we may be able to get them. Is there anybody from Intel on the call right now?
Yeah, we saw Jen was here just now. I think he left. I think see him now.
Who?
Jen was here earlier, but I don't see him now.
Jane?
Yeah, Jen from Intel. Gain, Jen.
Ali, Zane,
Yeah.
Zane, Tony.
Oh, it's Zane?
Yes.
Oh, okay, Zane. Okay. Yeah. Okay. So we could talk to him offline and see if they have anything.
Right. I just saw Roger just joined. Yeah, Roger, I think like for quick recap, I think like this is the Roger is from the ASC. I think he worked with Rihong. I think I hear him. I'm right. The ASC definitely working a lot like packaging side from the OSAC right perspective. So in this meeting, I think we talk about these materials design case. I think I will talk about like the use cases to define for these material models and formulas. So like and we can define separate and persona input output parameters. So I just want to quick check with you, right, Roger, if you have capacity can help on this one, that would be very helpful. Then I can kind of like bring you up to speed offline. I think if you're interested.
Okay, sorry, I'm sorry I late joined due to the urgent case. I see that. Let me check it. Okay.
Yeah, that sounds good. I think I will input. I think from you guys at SU will be very helpful. We define some initial structure. I think for many of these for the materials. And then we now want to go into a bit deeper on the formula and model. So I think that from there we need to start with the analysis and the persona input and output, similar what we done on that CDS workflow for that chip integrations. So I think we have a few volunteers here. I think if you we would like to have it would be nice to have more volunteers on this.
All right, got it.
Okay, thanks. Appreciate that. And I share the links in the chat group, but I also will send that meeting minutes with this link as well after the meeting. So back into this one. Yeah, we talk about the key site. I think it's like it just kind of quickly. I think like it what share with you guys here is we have that GitHub read last time as mentioned. I think like that created OCP, and then with that I just took some very initiative to put into some very basic structure into it. So let me try to share my screen quickly then on that tab. Give me a moment. Sharing. That's okay. Yeah, I just kind of took like what we have. I think originally I think with CDXML and we have some material properties there. I just kind of put in what we have discussed so far and just create a framework and put into the GitHub. It's just an initial draft. I think it's not like complete and comprehensive. I just probably want to also like include like a few models that we have modeled before that we can use that model as the object proper like that can be used on a different area. Like for example, CT can potentially in different areas. So we're going to create that object and actually use that example. I think that we have in the past and use that as a different places for references. I think as a starting reference point here. I think it's just more kind of foundation. So like as we continue to develop the spreadsheet there, I think then we have more information. We can start using this example and framework to expanding the list here. Then, it's just something I want to share with you guys.
Is this based on the JEP 30? Because I know JEP 30 has some provisions for defining material properties. So is that what this was derived from?
Yeah, I think it will be some. Yes, there's something we integrate with JEP 30 like the CT Young modelers. So yeah, we do it like kind of like synchronize with their models over there. So yeah, it's going to be like kind of in sync with the model over there. So later, I think I will also talk about later we're going to be integrate with them as well. I think that will be provide more seamless integration down the line as well.
Yeah, so let's do that before we get too far down the road, so we don't have to remap stuff, right? Let's just take what they have as a starting point, and then we'll build on that.
Yeah, we already many of these things already that from the previous. Some of them we integrated with them already. Some of that we already have that structure here as well. So we already have that kind of basic structure here incorporated here, so we can reuse that. So it's a same structures right to a JEP 30 there. Yeah, I think that's what I want to share here. Does anyone have anything else I want to cover in this meeting today?
Nope.
Okay. This call about now from Andrew, right? It's called about table, right? Around the table. John, anything like?
No, nothing else for me. I'll work on that spreadsheet, James.
Okay, thanks. And but yours?
Rajoosh?
Oh, Regis may not there.
No, I'm here. My mouse and my mute button.
Oh, okay.
Nothing from me.
Okay, thanks. Rudy.
I'm good. Thank you.
Okay, thanks. Roger.
No, thanks.
Thanks. Okay. Andrew.
Yep, good.
Okay. And David. You might be muting. Oh. Let's go. Right, Tony. Anything last from you?
Nah, I think I said enough.
Okay. All right. That's good. I think we do have a few agenda. I think for next time, I think we will focus on the use cases, and hopefully, I think we can get some kind of like initial. I think use case structure. I think to expanding on that model thing in the next meeting.
Yeah. Okay. Well, I appreciate everybody's inputs. I think we're starting to come together a little bit. So I think we're making progress slowly but surely.
Yeah,
Okay,
that sounds good.
thanks everybody.
Yes, thanks everyone.
Thank you.
Thank
Yeah.
you.
Okay.
Bye bye.
Bye-bye.